So let's go back to our fault finding flowchart. So now, is there power getting, let's go back down to this one, is there power getting to all the elements? In this case, now we're at yes. So let's go down here, release the toaster lever. Does the toaster lever latch down? No. Check with the multimeter, is enough voltage getting to the timer control circuit board. Well, this is exactly what we had to do in the previous toaster fix. So let's do that. Just a quick reminder that on page 2 of the flowchart, there's a handy schematic diagram which helps you identify all the main components in the toaster that I'll be talking about, and which are referred to in the flowchart. Right, I've got my multimeter set up, one side on the neutral here at the switch and one side at the feed to the circuit board. So let's give it a spin. Got it plugged in, switch on, set the multimeter to volts and then to AC. Toaster's on, 13.9 volts. So let's go back to the flowchart. Is there enough voltage getting to the timer control circuit board? I would say yes. 13.9 volts seems an appropriate amount. Remember in the previous video, on the other toaster, I was getting 20 volts. RMS or AC seemed high. In this case, 13.9 volts seems reasonable. So let's go down to the next item. Is the timer circuit outputting voltage to the electromagnet? Let's check that. Right, in this case I've used a clamp to hold the toaster down. So now let's try measuring the voltage to the coil, which is just, the contacts are just there. So let's do that. Plug in and it turns on. Set the voltmeter to volts. DC. $12.37. Just check on AC. I wouldn't expect AC with the toasters getting quite hot. Oops. Yeah, 0. So back to the flowchart. So yes, there's 12.37 volts DC getting to the electromagnet. So that suggests there's a problem with the electromagnet. So the card here is check the electrical conductivity of the core. So let's try that. Okay, set my meter to resistance, which is that one. I'm checking across the contacts here. That's giving 121 ohms. But remember, that's in circuit. What we really need to do is take the solenoid off now, or the electromagnet off the circuit in order to check it, because that might be just getting the resistance of the rest of the circuit. Now I need to get the circuit board out, and just a little note on this hole here which I've created. This is the idea of the service hole, and that enables me to get a screwdriver in there and remove the 2 screws which hold, you just down here see the cable connector, and then I can slide the cable away, and underneath that there is the screw that holds the circuit board So I'm hoping I can get that out without having to dismantle the whole toaster, take this back plate off and remove all the screws. So let's give it a go and see if I can do that. So if I remove, let's see, this screw, oh sorry, I've got the wrong one. I'm going to take that one out. Like that, through the hole. Just flick that out. Then I can swing I've already loosened that screw a little bit. Then I can swing that cable connector out of the way through the hole and get access to the cable. And then if I just create a little bit of slack, I should be able to just move that out of the way. And now, I don't know if you can see that, but there's another screw that's become exposed through that hole, which I can now slacken. And that's this one. Now, I think it's probably a good idea not to take it right out at the moment. And that will enable me to get the circuit board out. So I just removed the screws and the circuit board now slides out, so that means I can now get it off just by desoldering these contacts without having to dismantle the whole toaster, and hopefully I'll be able to get it back in. So now I've taken the circuit board out of the holder and removed the plastic piece and the core here from the solenoid. Unfortunately now, to remove this, I'm going to have to cut these plastic tabs which hold it in place. I mean, these are not really meant to be repairable. Anyway, so I'm going to have to do that, I think, in order to get it out. If only I'd stopped to think what I was doing here. But no, I went ahead and cut the tabs to try and remove the electromagnet and desolder it from the board, and in doing so I ended up breaking the wire of the coil and causing no end of grief. I'm pretty sure all I needed to do was to reflow or melt the solder of the contacts and it would have been okay. That's because the problem was probably just a bad contact between the contact or the pole of the electromagnet and the wire, and reflowing it would probably have fixed it. But you live and learn. Sometimes when you're repairing stuff you have to go 2 steps backwards to go 1 step forward, and certainly that was the case here. Oh no, when I was pulling it off, I broke the wires on the posts, so they should have been on there. Look, I can even see where the wires were. I was hoping that the posts would come out as well, but when I was forcing it out, ah dear. I'm going to try and measure the resistance of this coil with the 2 bits of wire that are still sticking out. Of course it's not going to be easy. 119.1 ohms. What? Yeah, so the coil's okay. So it was presumably the connection to the post that has gone wrong. So now what I've done is I've reassembled the electromagnet and scraped down the wire, soldered it onto these posts, pushed it back in, and now I just want to test that they've got the correct conductivity. So I'm going to put the meter onto resistance and check these terminals, see what resistance we get. $117 ohms, which is slightly less than we had before, as we would expect. I've chopped a bit of wire off. I had to take the tape off, unwind a bit of wire after taking the core off, and reattach it to the posts. I've quickly rigged up a little circuit to check whether my repair is working for the electromagnet. So I've got the keeper, the thing that latches down just in front of the electromagnet, and I've connected it to a 9-volt battery via a little switch. I've also got the voltmeter on here. So now, if I press this switch, do you see that? The electromagnet latches that keeper onto the keeper onto the electromagnet. Hey, it's quite nice, isn't it? And that's only with 9 volts or 8 point something. I've now resoldered the solenoid back in after reconnecting the legs. I had to undo this tape, get a bit of wire out, connect it to the legs, resolder them in, and I've also, where I'd cut these plastic tabs, I've now inserted a screw from a pair of old glasses, which was a self-tapping screw. I used my solder iron and just created a little hole, and then with a needle I made it larger, and now I believe it's better than it was before, because you can now remove it if in the future I need to replace the solenoid. So let's now to reassemble the toaster and to the point where I can test it again. I finally got it together enough to test, so now let's see if it will work. Plug in, and let's see if it will latch down. Yes! Works! After all that, yes, seems to be working. I'm just going to turn off. One thing I'd like to mention before I reassemble it, if you look here, you can see there's a component that's sticking into the toaster. Now that looks like some sort of thermal fuse or thermal protection. So if the toaster gets too hot, that could be one thing to check straight away, because that may blow. So there we have it. I've got the toaster together. So let's see, and let's demonstrate if it works. So I've got it plugged in. There you go. Latching down. I don't have any toast at the moment to make. Just check that that eject button works. There you go. So it turned out to be a slightly more difficult fix, in that, going back to the flowchart, we had one application that went this direction, and then we came back and went down here. So if you would like a copy of this flowchart, then I'll make a link available in the description. And if you want to leave some comments about whether you think that's useful, let's face it, not everyone fixes toasters every day, so it's good to have something to follow if you need to fix your toaster. So let me know any comments, and I'll update it if required and make a new one available. Thanks for watching, and I hope you find this a bit useful.